solving equations. Now, that's a little, I feel like a little misleading because some of them, of course, nice, easy, I can move this, linear equations. Just throw it on my desk, Riley. And then, of course, we have some that are quadratics, some third degree, some crazy stuff in there. Notice, though, the title is graphically. So we're going to do a few algebraically just so we see the connection to the graph ones, but most of them we're solving in your graphing calculators today. So that's why I said have your calculators out. I'm going to show you that today. Also, we're going to do some inequalities. Think about, what was it, 1.8, our section with all the inequalities, your infinite amount of answers. I'm going to use interval notation again, smallest to biggest, those intervals to write my final answers. Might have some and ors. Just see what we got. So that's what we're working on today. So really, we all know how to solve equations algebraically. That's not going to be that stressful. There's nothing too wild there. You might have to use, completing the square quadratic formula, which is a good review. I'm happy about that. Let's talk about graphically. Now, if we're going to be honest, to me, this is a ridiculous example. Because wouldn't you just solve that quick in your head? Like, I wouldn't even write anything. I just put the answer down. Let alone type it in my calculator and go through all of that shenanigans. But there are some uglier, tougher equations that it is nice to solve on the graph. So same principle, but that I do by hand. So to solve by graph, notice it says move all terms to one side, set equal to y. So if we were doing this on the calculator, I'm going to subtract 1, so it's set equal to 0. In your, like I said, I would never ever do this on my calculator. And your y equals menu, your y1, you're going to type that in. So notice the 0 is where the y1 is. So you have to think about where is y0. Y is 0 on the x-axis. You're really finding the x-intercept, which I'm going to show you how your calculator will find that point for you today. So when I'm solving equations, putting it in the y equals menu, and I'm looking for where it hits the x-axis. Now, they're not all going to be nice, pretty whole numbers, obviously. So I'm going to show you how your calculator will find those for you today. Now, first up, they're just wanting you to see the relationship between solving it algebraically and graphically. So solve it algebraically, graphically, find all real solutions. Okay, use the algebraic method and the graphing method. So let's start algebraic. Plus, this is good review. I like to review always. Quadratic. I'm going to try factoring, completing the square, or quadratic formula. I'm like, oh man, it doesn't factor. Nothing multiplies to 2 and adds to -4. Personally, I think this is a good one to complete the square on because I can do half a b and square in my head pretty easily. So let's review completing the square. I'm going to move the 2 over to the other side. So I just subtracted that off. I'm going to replace this term. Remember, the purpose of completing the square is it forces the trinomial to factor. So complete your square. Half a b, half a 4, 2 squared. I'm going to balance on each side. So left side, of course, now factors. Multiply to 4, add to -4. -2 plus 4. I'm going to get rid of my squaring. Don't forget plus or minus for your 2 answers. And last but not least, let's add 2 over. Okay. So we technically have 2 answers, 2 plus the square root of 2, 2 minus the square root of 2. Now here is the graph for it. Let's do the graph. We should kind of have an idea what the graph's going to look like. Squared, quadratic, it's going to be our parabola. More importantly, parabola that opens up with that positive lead coefficient. Get that out of the way. So x squared, remember x is next to that green, well mine's green, the alpha key, -4x. Make sure you use subtraction, not the negative key. Let's hit graph. And one other thing too, just to point out, at any time if your window looks different than mine, hit zoom 6, puts you back on the standard 10 by 10. So I'm just going to steal this over here for a sec so I can write on it. So 2 plus or minus the square root of 2 are technically these 2 points here on your graphing calculator. Now, it's hard, your graphing calculator is not going to spit out to you 2 plus the root 2, 2 minus the square root of 2 when I find them. It's going to give you the decimal equivalent. So, I'm going to pull the calculator back up. To show you how to find the actual zeros, to have it do it for you, you're going to hit second at the top and then trace. So you probably didn't do this much in honors geo. This might be new to you. So second trace, and you want number 2 is the 0. Now you can see my cursor is kind of up here on the left side. I'm going to find this leftmost green dot where I marked on over here. I'm just going to right arrow and cursor them a little closer. I'm going to keep the cursor above the x-axis right now, above the x-axis. I'm going to hit enter. Then I'm going to keep right arrowing and put the cursor below the x-axis. Anywhere there, good enough, enter. Nobody wants to guess, that's just stupid. Texas Instruments, I'll try to stay off my soapbox. And there we go. So we've got about 0.59, I'm going to round it to, comma 0. What was it, 0.59? Yeah. So that's the first one. Now, to get the second one, you have to do that same process. So let's practice again. I got to do second, trace, number 2. Now, I'm going to right arrow and cursor them closer to that point. I'm going to leave the cursor below the x-axis somewhere. Oh man, I hate typing on this thing. Come back, cursor. I only hit it like 3 times. Last hour it jumped up to like 484 on me on one. Like seriously, there it is. Come back, come back, come back. Okay, below. One of these days, I'm gonna get it. There we go. Okay, below, enter. Above the x-axis, enter. Nobody wants to guess. There we go. Now, notice you get sometimes this weird looking message, 1e negative 12. On your graphing calculators, I don't know if you know this, the E is what it uses to represent scientific notation. So that is really 1 times 10 to the negative 12, or point 0, 0, 0, 0, 0, 0, I don't know, 11 zeros, I don't know how many said, a bunch of zeros, 1. That's as close to 0 as your calculator will get it. I'm going to round this to about 3.41 here. Let me write that down. Now, are these answers, let me pull my calculator back up, are these answers really the same thing? Yes. You have the exact version, the decimal approximation. If I, let me get out of this, type in 2 plus the square root of 2, 3.41, which my calculator is covering it up. If I type in 2 minus the square root of 2, I know you're going to be really shocked here that we get 0.59. Okay, so that's just the difference between algebraic, your exact answers, or of course the decimals off your calculator. Elliot.
How do you input the parabola equation onto the y equals menu again?
So hit y equals, and then remember your x key is up here next to alpha. I just typed it in, x squared.
You typed in the top.
Yep, the x squared minus 4x plus 2, yep.
I tried to type in the factor.
Oh, gotcha. All right, I'm going to hit delete here off of that. Get my green dots out of the way. Okay, now, same thing. Says solve a quadratic, algebraically, graphically, blah, blah, blah. This one's a little nicer because doesn't this factor for you what multiplies to 4 and adds to negative 4? Yeah. So, of course, we do technically have 2 answers. They're just both the same. So, when you go to graph this one, I know it's a parabola, squared. It's going to hit the x-axis only at one point. Meaning, watch this, the vertex is going to sit on the x-axis. So let me clear this, type this guy just to show you. Don't judge how slow I type. And there you can see the vertex is sitting on the x-axis of 2. Also, just to show you, because I know some of this calculator stuff might be new to you, if you look in your table, hit second graph, you can see you have 2, 0 in there, equal to 0. So that's another way you can verify that it is actually hitting it 2 comma zeros in the table. All right, that was a nice easy one. Like it. We hit next here. All right, another one. I'm like, oh man, doesn't look like that's going to factor. Nothing multiplies to 6 and adds to negative 4. Again, I think this would be a good one to complete the square on because I can do half of 4 pretty quick in my head. So I'm going to first move the 6 over to the other side because it wants algebraic and graphically. Eventually, we're just going to do all graphically. And then, of course, I'm going to complete my square on the 4. Half of 4, 2, 2 squared, 4. And again, it's good to be good at completing the square because it comes up a lot this year. It's a good practice. Shock, multiply to 4, add to negative 4, seems a theme here. Negative 6 plus 4. Ooh, good, I'm glad we get to review this. Get rid of squaring with a root. Square root of a negative. Now, I'm excited because I have a square root of a negative. That puts it into what type of number? Imaginary. Yes. Plus or minus. I had to take I out for the negative. Luckily, the square root of 2 is prime. I don't have to simplify it. Last but not least, I'm just going to add the 2 over. Okay, let's graph it. There's my exact algebra answers. You graph it a second. You graph it. I know what that's going to look like. So I'm doing my x squared minus 4x plus 6. And I will hit graph when you try it first. I'm going to have any graph and calculator issues. And then take a look. What's happening there? Take a look, hit zoom 6 maybe. Take a look, where does it hit the x-axis? Nowhere. Guess what? I knew that before I even typed it in. What tells you that it's not going to hit the x-axis? Imaginary. Anytime you have imaginary answers, because I'm sure you got this picture, anytime you have imaginary answers, I knew it wasn't going to hit the x-axis before I even looked at the graphing calculator. So would I have even really bothered to type it in my calculator then if they're imaginary? No, it's not going to hit it. It's not going to help me. But if you want to verify your answer, if you're worried if this is correct, that's how you can check that. Okay, solve the equation algebraically and graphically, of course, in our calculator. Now, let's get real. Is this one I would bother doing on my calculator? Can't we just solve that like a good old 2-step algebra 1 equation in like 2 seconds? Yeah, okay. So I'm going to solve it. I'm going to add 3x over. I'm going to add 20 over. And we have 25 11ths. I mean, yeah. Not to bore you. If you wanted to solve this in your calculator, which again, I find super duper irritating on something easy like this. You would have to set it equal to 0. So I'm going to add the 3x over, and I'm going to subtract 5 over, so it's set to 0. I'm already bored with this. I'd have to type this into y1, and I would graph it and see that that's where it hits the x-axis. To me, that's a whole lot of work for something we just did in like 2 seconds. So I'm not going to get carried away on the graph on this one. Okay. Oh, okay, definitely want to do this guy in my graphing calculator. I don't know about you, but I do not want to try to solve that equation by hand that's not only got a 3rd degree in it, but we also have that square root of x. And I'm going to help you with that interval part here in a minute, okay? Now, first things first, we have to set it equal to 0. So I'm just going to subtract the square root of x over. So that's the first thing I'm going to jot down here. I don't care what order the terms are in. Got it. Now, we're going to type that crazy looking thing into our y equals menu, and we're going to change our window too. So in y1, you're just typing this in. And we're going to see where it hits our x-axis. So, you guys are probably ahead of me. Let's start typing this one in. I'm just going to grab mine because I got it up. The calculator's covering it up here. X cubed. Make sure you right arrow after you do your x cubed. Get out of that. 6x squared. Plus 9x. Minus square root x. Okay. Now, this one's getting super specific on you, meaning in this interval, what they want the answers for. Remember, we are solving for x. So this is the range it wants you to look at for x. We only want the answers between 1 and 6. So what's kind of nice, before I hit graph, which I'm going to hit graph here, you probably already did, instead of me be like, oh, where's 1 to 6? You can just change your window so it specifically goes from 1 to 6. So if you hit window at the top, I'm going to change hit window at the top, x min to 1 and x max to 6. And now it's going to readjust my viewing window and only show me the x-axis. It's going to blow it up from 1 to 6. So hit graph. Okay, I like that. That's a little easier on the eyes, my old lady eyes, than when I was on my normal window. So I want these 2 answers where y is 0. Your x-intercepts where you're on the x-axis. I'm going to have my calculator do all the work. I'm going to do my second trace. And remember what the 0, that's synonymous for solution. Where's my cursor? I'm going to do this left point first. So I'm going to left arrow over. I'm just going to work left to right. That's how I'm going to roll here. Try not to hit it too many times so it gets crazy on me. It's a slow moving cursor. Come on, little buddy. You can do it. I find it helps to encourage him. Maybe. Come on. Goodness gracious. All right, he's finally over there. So my cursor, I'm on the left side of where it's hitting. I'm above my x-axis. I'm going to hit enter. I'm now right arrow till he is below the x-axis. I'm going to hit enter. Nobody wants to guess it's done. So I'm going to round that. It doesn't say what to round to, so let's go. I think your homework says 2 decimal places. So I'm going to put 2.18 for that guy. If it doesn't say what to round to, I really am not going to obviously be super picky. My rule of thumb is I usually do 2. Now I got to find this other guy. So second trace number 2 again. You got to go through the whole process again. So second trace number 2. I'm right arrowing. I'm getting him closer to the point. He's very slow moving, this little guy. I'm going to keep the cursor below my x-axis once he gets over there. Okay, so there's my cursor. He's below the x-axis. I'm going to hit enter. Then I right arrow some more till he's above it. Nobody wants to guess. It's stupid. All right, and let's round that. I'm going to put 3.72. Now, let's not forget, I messed up your standard window. We like it normally on the 10 by 10. So before I even think about doing the next problem or anything else, I'm going to fix that really quickly. I'm going to hit my zoom 6. So now you're back to your normal viewing window. Okay, so easy stuff today. It's just, well, maybe I just type slow. It's just time consuming to punch all of this in your calculators, if you ask me. So, inequalities. Now we're going to switch over to inequalities. It's really the same process, so to speak. Of course, solving an inequality, we've done a truckload of those in 1.8 algebraically with our number lines and testing the number line. We're going to do them on our calculators. So kind of the same setup. You want to set it to 0, same deal, set it to 0, and then we're going to take a look at the graph. And you have to look at your inequality symbol. Greater than 0, I'm looking for above, less than 0, the portion below. So we're going to look at our symbol a little closer today. So, I think you're already typing it in. Okay. This first one's already set to 0, so we're ready to type it. Hear all the calculator keys clicking. All right, so I'm going to just steal this picture so I can draw on it. Power of the smartboard. Okay, so what am I after? Well, we want to know solve the following inequalities using graphing calculator. Key on this guy is less than or equal to 0. Well, it equals 0 right here on the old y-axis, of course. Less than 0 is going to be the portion below it. So what we're after are these intervals for x. So, I mean, it looks like it's from 2 to 3, okay? It looks like x is 2 to 3, but I wanted to find it kind of exactly where it hits, and I really marked a bunch of stuff on that picture. Now, when I look at mine, because I can blow it up, it does look like it hits right there at 2 and 3. I do not want to have to do second trace number 2 if I don't have to. So I'm going to just quick check on my table. And I'm like, yes, 2 and 3, I was right. How do I know it from the table? Because you have 0 for y. It's right on there, 2, 0, 3, 0, yes. So I'm going to draw this back in now. So below, less than or equal to 0 is the part below. We want the answers for x from 2 to 3, and I'm going to write it in interval notation. Just to relate this back to what you did in 1.8, don't write this, just look at it. This would be the same if I said, hey, factor this out. Put your numbers on the number line and do all this testing. And you're going to see it's going to be an and graph in the middle. I just saved you all of that work from 1.8 by using your graphing calculator. Okay? That's what we're doing. All right, now this guy, we just have, let me move this graph out of the way here. Let's delete him. This one, before you start typing it in your calculator, all that stuff out there, we first need to set it to 0. Always set it to 0. That one's not going to be so bad. This again, it's not too bad, but we need to move, I'm going to move the 2 over. Notice I'm keeping my like terms lined up, and I'm going to add 1.4x over. I'm going to kind of sneak it in there. My 1.4 kind of tiny. Okay, so I'm going to rewrite that guy, 3.7x squared plus, I'm going to add those together, 2.7x. I'm going to total that. Okay, so start typing that one in. That's going to be a parabola too, with the squared. We just have kind of yuckier numbers. 7x squared plus 2.7x. Got it. Okay, well I'm going to steal the picture here. So of course we're looking where we hit 0. Oh man, those are decimals, so I'm going to have to second trace and find those, which is going to be a little obnoxious, but I'm going to do it. And then less than or equal to 0. So I'm looking at the portion of the parabola less than 0. I want the bottom portion. So I'm going to be between these two numbers. We would have an and style answer, of course. The only bad part is I got to do second trace and find these exact numbers because they're decimal, I don't know what they are. Okay, so second trace, number 2. Let's do the left one. I'm going to left arrow over till he's above the x-axis. Oh, more, there we go. Right arrow till he's below the x-axis. I'm going to hit enter. Nobody wants to guess, just hit enter. So that's at about negative 1.45. I'm just going to write that on here. Just to save you the time and watching me type on the calculator, nobody wants to see it. I did this one earlier, it's at 0.72. And of course, less than is the portion of the graph below those numbers. So our and. So there's my interval from negative 1.45 to 0.72. Okay. So next one, notice we switched to a greater than symbol. I thought we should do a greater than symbol. So greater than, on the next one, I'm going to be looking for the portion that's above the x-axis. But we'll get to that. Let me delete this out of the way, and let's type this guy in. Now, again, set it to 0. So I'm going to add 8 over. But you can just do in your calculator. I'm going to write it down for us. And let's get that guy typed in. Erase all of this. All right. You guys are probably already typing x cubed. And then plus 8. Hit graph. Oh gosh, we got a little loop-de-loop action here going. So I'm going to steal my picture. Power technology, it's nice I can write on it. So of course, we're looking for the zeros first. So I'm just looking at where I'm hitting the x-axis. That looks like a decimal to me. I'm like, ugh. That looks like a decimal to me too for me to find super funzo. And so does that one. Okay, swell. Okay, great. All right, so that means second trace, number 2, 3 times. Get excited for that. But, let's look at our final answers. Greater than or equal to 0. So above. So I'm looking at this portion of the graph and this portion. So we're going to have 2 intervals. One for this guy and one for this piece. Well, let's work on this one first. Now, we don't need to watch me type second trace number 2 again, do we? No, we don't. I punched this in earlier. This guy's at negative 1.1. I just rounded to the 10th on this one. I don't know why, I just felt like it. This one I typed in was at 1.5. And I did type this guy in earlier too. He was at 4.6. Just to save you watching me do second trace number 2 a million times. Now, this part of the graph that's above your x-axis is the part that's between negative 1.1 and 1.5. So I'm going to have my and answer, or my interval, negative 1.1 to 1.5. So that's just that left red piece. I've got the other one. Or, gotcha. Now keep in mind, your graph goes on forever. So we're from 4.6 going on forever out to infinity. So you have to look super close at your symbols. Greater than, you're looking where it's above. Less than, I would be looking at the portion below. So just look at your symbol closely, okay? So any questions on the graphs? I think today's easy. It's time consuming. Well, for me, maybe you guys type faster than I do. It's just time consuming to punch